Welcome everyone to the next talk on our second day at YUIConf 2012. I'd like to introduce to you Bishan Kochar. He's going to talk about secure coding with YUI. Let's give Bishan a big hand.
Hey guys, thanks for coming here. So my topic is secure coding with YUI. My name is Bishan. I'm a security engineer at Yahoo. And I have nearly 13 demos today for this session. And I'm going to put all those demos in my GitHub repository maybe a couple of weeks after this talk. OK, so what is secure coding essentially? So if you look at everybody has different interpretation to what secure coding is. It might be X for you, Y for me. However, if you look at history, there are some trends. There have been some things which have been happening. So if you just look at the industry of software industry, you've had issues of buffer overflows in terms of C++ software, and even the servers that we see today. On the database side, we have had a long history of SQL injection issues. Similarly, on the front end, we have something called like cross-scripting, which is a #1 security issue in the web today. And it has been such a big issue that it has been discovered for nearly more than a decade and a half, and it still continues to be the #1 issue. And this is a stat from XSSED.com, which maintains the database of all the cross-scripting issues officially reported. So it counts to 45,600, and yesterday there were 4 issues reported. So you can see it's a pretty serious security issue. So what is the impact? Why is it so bad? Why everybody is so, so there are 2 things here. It is very bad, so we'll see about that, why it is so bad. And second, it is very, very difficult to fix. I've been doing security for more than a decade, and if you ask me, this is the one security issue which is most difficult to fix, and I foresee it to be existing for the next 10 years as well. So, well, that's my prediction. So I'll try my best to cover most scenarios and give you a guideline, a checklist, or maybe a cheat sheet, few steps. If you can go and implement that, I think you can eliminate nearly 85% of cross-scripting issues, and not without too much work involved in that. So talking of the impact of cross-scripting, you have a number of them. So the script kiddies, they essentially come and deface your site. Hey, I just got to you. And they're guys, you just go to a site, they steal your cookies, they log in as you. And they're like guys, for them it is profit. They install malware into your machines and compromise the machines. And I'm going to show some of those demos. So my first demo is about, I know many of you know here what cross-scripting is, but I think it's very important to show the impact of it, because my next 13 demos, they will essentially give you pop-up alerts. So you'll say, what is this? But essentially, whenever you can pop an alert, you can essentially execute JavaScript. So what I'm going to do now is I'm going to show a demo. We're going to do a defacement. We are going to do a login overlay, essentially telling a user that, OK, you need to re-log in. And you can also steal cookies. So here's my first demonstration. So this is a regular request and response feature that you see in any of these sites today. So you have a request, it comes in. Now, what would happen if an attacker pushes in some special characters, maybe the script tags, or maybe the brackets, or double quote, single quote, X engrave character. So we'll see that. Now, what I'm doing here is I'm injecting a script. I'm calling a malicious script. Let's see what it does. So at deface, so this is a regular thing, this is like the regular script kiddies. I just want to show we can do stuff. But smart attackers, what they would do is they would essentially try to do some more profit with the attack they just found. So this is another script which essentially did a login overlay. So a real user, he has no way of knowing like what the real login screen and what a malicious login screen is. Now, if you look at what has happened here is the script, I injected the script tag that was included as part of the HTML response, and you had a cross scripting issue. This is in bare bone nutshell what cross scripting is. Now, so in the pure JavaScript world, I'm not going to talk about all the varieties of cross scripting. What I'm going to talk about is the most relevant in the context of JavaScript, which affect the JavaScript directly. So there's one very popular one, which is called as DOM XSS, which has picked up a lot of relevance over the last 1 year. There's another one, which essentially is the old XSS, the reflected and stored XSS type 1 or type 2, which is still very relevant. Then you all know, using insecure calls like eval are bad. But today I'm going to show a much serious demonstration which has a huge impact. Just imagine if you have eval on the server side. I guess some of you guys who just came in early, they probably saw it. So you can essentially own a system. So JavaScript is, once you put it on server side, you can, if you do a cross scripting, essentially you can own the server. So we'll see that in the context of Node.js. And it also has, JavaScript is the language of the browser, and now not just the language of the browser, it is probably language of the internet. Now, it also bridges with PDFs, docs, Flash. So whenever you have that bridging, you'll have cross-scripting issue there as well. I'm not covering those, but the idea is the concept I'm going to be talking about today. If you take care of those specific guidelines, you should be fine with these two. Okay, so DOM XSS origins, like most security issues, it did not pick up steam when it was found because it did not have rich application. There's a nice researcher. He figured it out in 2007, but 2005, sorry. It was 2007 actually. Yeah. No, it was July 2005, sorry. So he found in 2005, it took nearly 6 years for it to really become that big. And the main reason behind that was nobody was doing a lot of JS programming. And when they started doing it, you had security tools, the dynamic scanners, the static scanners. They didn't have capability to find these issues. So you had security depth piling, a lot of rich apps coming. And then a few companies come, IBM, Minded Security, they do some analysis and they figured out thousands of security issues on Alexa top 100 and Fortune 500 sites. So before we go on to demonstrations, I want to talk about how it happens, what are the sources and sinks. It is very important to understand where this attack can happen, where you take the untrusted input. So this can happen from the URL. You can take untrusted input from a user from the URL. It can happen from the forms, Ajax. Now you might wonder, how do I, if it's happening over Ajax, and how do I, exploit it? So I'll have a demo for that as well. And the interesting part is now with HTML5 storage, it is no more reflected XSS. It essentially becomes a persistent XSS. So essentially, if you get hold of one victim and install some malware or maybe some bad code onto the local storage, it is game over. So in terms of the sinks, you have inner HTML and the likes, like doc.write. You have eval function, window.location. There's a huge list of sources and sinks. Do not worry about it. What is more important here is how to do secure coding. So if you do that, it is irrelevant what sources and sinks exist. So we have a complete reference here. So this is my second demo. So what's going to happen here is, this is the concept of DOM XSS. So essentially, why tools do not catch DOM XSS is because you do not see the attack payload in the response. It is not in the view source. It is in the generated view source after a DOM operation has completed. So let's say, again, we have a similar feature, and let's say there's a partner or something, and this is my Scrappy application, and it just receives something and says, okay, Scrappy for okay. Now, if I have a XSS here, and most tools that we use today are, even when we are doing manual reviews as security folks, we do not find the attack payload within the view source. As you see here, the tag is empty. But when you go on to so view source will never have the attack payload in DOM XSS. But when you do the inspect element in your Chrome, and then you can see that node being added. So this is where you see the injected payload. Okay, so here I'm using the IMG, so I also get queries sometimes that if you cannot use script tags, you cannot do cross-site scripting. However, if you can, JavaScript is everywhere. It is all across. So if you put an IMG tag, you can do an on-error alert. And you can, so this is the last time I'm going to be showing that alert is a security issue. Okay, so for the last time, we will do another variety of XSS, which essentially you can do a redirection. You can send people to phishing site. So I'm going to use the image tag again, and on the on-error handler, I'm going to send it to doc.login to yahoo.com, where you want to increase the traffic. So okay, so all right, so that completes the second demo. So if you see, the issue here was dynamic HTML coding, because we were taking input from the URL and putting onto set HTML. Now, this is a very bad way of coding, because whenever you put something onto the HTML, it is just going to execute. It is untrustworthy. Now, this is similar to YUI set HTML, and I want to make a point here that it is not an issue with YUI set HTML. It just uses it in HTML. It is just a bad programming. You need these APIs where you are very sure that my data is extremely, extremely trusted. You use set HTML. If you're not, you should not use it. And what you should be using is the text API, because that will convert whatever you have into text form, and that will not execute, which essentially is set text in YUI. And second recommendation is, if you are building rich application, it is always, always good to have something like handlebars, mustache, templates, which can do the auto-escaping for you. Okay, so yeah, first takeaway. So if you do this, so if you are extremely good of knowing where input is coming from, or by default you're putting everything as set text, or you're using auto-escaping engines, you're going to be getting rid of 70% cross-site scripting issues. Okay, all right. So second one is form-based. Now we do not have URLs. Now I'm just attacking myself. It does not look so cool. Now what about you are at home, you are logged into some super sensitive site, and there's a popular game, alphanumeric hero for kids. Your child loves it, Control T. He starts playing it, and you just realize your account is compromised. So we'll see a demo for that. So this is my alphanumeric hero for kids game. It uses clickjacking, which is one attack where you can put a victim site under an attacker site as an iframe. And there's a feature in Firefox where you can do a drag and drop. You can drag stuff from one place and drop place into another place. And then we have self-XSS. So together you can get a ownage. So let's see that. And this happened. This is very popular. It happened with Google App Spot as well, where it became very popular. One of my friends found it, and it was the fix for very simple. Use create text node in Firefox, or use set text in YUI. So let's see a demo of this. So this is a very simple Ajax form, and let's say I just say hi to myself. It's a very crappy application, but you get the point. So and then I just try to attack myself, which is not a good thing. So, okay. But this is what attacker wants to see. So once they know, and let's say there's a popular game or whatever, something you land upon, and okay, so the challenge here is we have a secret cookie, a token that we want to steal. Now I am going to be popping up the token, but you get the point. So all my previous demos where I was like doing all those redirects and this thing and that thing, you can steal the token that way as well. So now we have the alphanumeric hero, and my son is playing, and he drags, and my cookie is gone. Okay, so I could do anything with it. Let's see what happened here. So essentially what I've done is there is a iframe. I'm going to make it visible. So I set the opacity to 0, so it was not visible. I'm going to set it back so you can see what essentially was going on. This is the Ajax site which was there, and I used the drag drop API to put the attack string. Okay, so let's try that again. And then I've overlaid the buttons. So that is how to exploit self-XSS. All right. So now with HTML5, whenever you have more features, the web becomes more powerful. The attacks become more powerful as well. So now you have HTML5 storage. You have lots of ways of doing storage. I think IndexedDB, local storage, and offline cache, a few more. So what you're going to see here is that, so again, the issue here is not doing escaping. However, if you're using auto templates, auto escaping templates, and if you're using triple braces or the equivalent which can do the unescaping, you'll have issues again, which is again a very common abuse case. Now, so this is a application which I modeled from one of the YUI demos, and I just made it vulnerable. So what I've done here is I have used a triple mustache, and that will convert the safe data into unsafe. And this will be persistent. We'll see that. So again, I'm just popping something, but a real attacker will put some bad software. Like whenever you go to this site, you go somewhere else. It keeps asking you for something. It keeps performing actions on your behalf. So let's say I'm done with it. I come back, I refresh, I reload, the next day, and it's going to work again. So it's like you inject once and it is done. Okay, so that was about persistent XSS with HTML5 storage. The second summary, the second takeaway here is, again, what was the first one, which is use the text nodes, which essentially is set text, and use auto-escaping templates. And if you're using that, ensure you're not using triple braces. So with that, if you're using attributes, again, now there is a bad way of doing it in YUI. I see a number of cases with y.node.create where this is again dynamic HTML. You are essentially taking input and putting back onto the DOM into the node create element. The right way of using it is set attribute. This is called as DOM construction. DOM construction is the right way of coding securely compared to dynamic HTML. So we'll see this case as well. So what we have here is we have two cases. One is a vulnerable case where I'm essentially putting the untrusted data onto the value attribute. And the second one is where I'm constructing the DOM. So we'll see with the same input, with the same feature, same behavior, one is vulnerable and one is safe. Okay, so this is a regular use case. Now, what an attacker will do is they'll send you a URL somewhere. You might not click it. It might be embedded somewhere, or you might click it. And when that happens, you could have two buttons. So the safe one, it is fine, and the second one, it is not. The code is executing. Right, so if you use set attribute, YUI set attribute, YNode set attribute, it is safe. If you do YNode create and put HTML onto it, that is dynamic HTML, that is not secure. So the right way of doing DOM coding is DOM construction. And that's the, again, takeaway added to the first one. So whenever you are not able to use set text, use set attribute. Okay, now there's an interesting piece here. Now, why I've been saying 70% is because mostly we work with HTML. However, with rich applications, you also do URLs. You put stuff into other contexts, into CSS, into URLs, onto on handlers, onto JavaScript itself. And maybe there's another language tomorrow you'll put within that as well. So we'll talk about those. Now, here I have another use case where I want to take a URL from the user and put it onto the DOM. Or I'm going to take a parameter and put onto the handler, on handlers. Now what is happening here is, although I'm using the safe DOM construction, which is set attribute for href and set attribute for on mouse over, I'm still going to have a cross-site scripting issue. So let's see that. So let's say this feature, it takes in a parameter where I'm calling a JavaScript URI, and that executes. Again, you could have anything instead of alert, you can do multiple attacks. Now, what has happened here is I'm using safe DOM construction, but still I'm getting a security issue. Now, another case is, let's say I'm taking some user input and using it somewhere in some variety in my on handlers. Now again, the catch here is URL attribute has the capability of invoking the JavaScript parser, and same with the on handler. So whenever you have that, you're going to have these context-specific cross-site scripting issues. So if you do this one, you're going to be having 85% prevention from cross-site scripting. Now, so what you could do is, there's a complete reference. It's depending on what you use. I'm not covering all the cases. You have issues with HTML. You have issues when you're doing something on this browser with CSS. So there are different variations. So you could look at this reference and see what suits you better. But the higher level, the most common abuse cases are if you have URL context, if you are taking in user-generated URLs, then always ensure it is beginning with HTTP or HTTPS. And also URL encoded, because there's another security issue called HTTP that happens when you do not encode it. So that's one. And second is on handlers. Yeah, don't include untrusted data into on handlers. Include within the JavaScript directly. And it should be quoted. That's the next demo. Okay. So, all right. So auto-decoding, this is another interesting feature. Now, the browser is not one language. Essentially, it is multiple language. They all have different ways of doing things. They have different encoding schemes. They have different parsers. They send stuff to each other, take stuff from each other, and when they do that, they do some transformations. Now, I don't know whether these are like features or these are defects, but I'm guessing they're not fixed, so probably they're features. So let's see. So two rules here are that do not do get text and put onto set HTML in YUI. If you do that, you'll have a cross-site scripting issue. And HTML to HTML is safe. So if you are taking get HTML, putting it to set HTML in YUI, it is fine. If you take a node using get text and put it into set HTML, you're going to have a cross-site scripting issue. So this is we'll see a demo for this one as well. Now, what I'm doing in the vulnerable cases, I'm taking a node which is already safe. Okay, so this has the safe content already encoded. And when you call get text, it is going to decode automatically. because I'm calling different APIs, so they think something has to happen and something wrong happens. Now, when you're using the same API, it is fine. Auto decoding, okay. Oh, this is another one. Just a second. This is the one. Auto decoding. Okay. Yeah. So I have two different buttons. One is safe usage and one is the unsafe usage. So this is already escaped, so you're already safe. And when you call with the get HTML, put back into set HTML, you're fine, there's no security issue. However, if you call get text and it's going to be converted, it's going to be decoded, and it's going to execute. Okay, so that was another, you can call it an edge case. Okay, then you also have auto decoding happening when you put even encoded HTML, escaped HTML data into the on handlers. Now, let's say I have a function here, and for some reason I'm putting the user-generated data into the on handler here, and it appears it is encoded. Now, what happens is within HTML, when it hits the JS interpreter, it tells, okay, it's an on handler, and it might not understand what I understand, so I'm going to decode it. And when you decode it, you're going to have a cross-scripting issue there. So let's see that. Okay. So let's say there's a buy one, get one deal, and there's some features. So I'm not very good with features, so just pardon me for that. Okay, so you have an XSS here. Now, if you go in the page source, it is surprising it is encoded. It should be safe. However, when you go to in the generated source, it is not encoded. So that's about auto decoding. Okay, so I said earlier, never leave your attribute values XYZ, which has to be encoded. Make it always coded. If you do not do that, you're going to have another cross-scripting issue. So this happens in the context of HTML, in other languages within the browser as well. I'm just covering for JavaScript. So let's say I have a variable here, which I'm taking from the user as ABC. What if an attacker just puts a function, a JS function, and comments the remaining statement? You're going to have a cross-scripting issue. Okay. Okay, so that was about uncoded attributes. Now, the defense is pretty simple. Use quotes. Okay, now there are some edge cases with IE. There are edge cases with all the browsers. I'm just covering IE for the simple reason that the IE browsers, they just manage to stay for longer. So all the issues manage to stay for longer as well. Now, ideally, when you specify application/JSON, your browser should understand it's going to be a JSON and just download if it is not going to be required by a AJAX, a DOM page. Now, what happens within IE is it has a sniffing feature. It just tries to be very, tries to be very intuitive and sees that if it is not able to find HTML, it just goes, looks at the It's an application JSON. It does not know how to display it. It just goes out to the URL, sees if there is some extension which it can display. Now, as it turns out, you can put within PHP, this works in Apache servers, this works in IIS servers. So even after a PHP file, if you do a /.html, which I've done here, so IE tries to sniff this URL and sees, okay, I see an HTML, so probably this is an HTML, and it's going to execute it. So that's the next demo. Now this thing does not work in Chrome. So as we see here, in the response headers, it is being sent as application JSON. So defense here is to use a header called as no-sniff. Now, it might also come out as a W3C security header. There is already a recommendation made for it by Microsoft as a feature. And if you don't want it, you can turn the feature off by doing no-sniff. Now, the catch here is this will not work within IE6, IE7, and they are still going strong. So what you could do is, strong filtering at the server side. Now, I've not covered all the demos for IE and other browsers. So as it turns out, you have lots and lots of edge cases all across. You can even have an image being downloaded on IE6, which can execute JavaScript. So best way is always try to do as much filtering if you're taking user-generated data like images, PDFs. Always try to run it through some standardization software, and always force the download if you want to ensure it is going to be a downloaded file. You can use application octet stream. You can use whatever extensions you are sending. Okay. Right. So I already covered this. Okay. So this is the I guess the second edge case we have for this is it was identified much later. Now what happens within IE is it tries to be even more smarter. It tries to figure out if there's a delimiter, and if it sees X engrave, it uses that as a delimiter for the fields. Now, what is required for this attack to happen? So, when let's say you have a So let's say there's an input field and it has a double quotes in front of it, but I just put 2x engraves, and the rule here is you should not have any spaces. If you have space, it does not work. Having said that, there are a lot of ways of doing it, but I've not tried those. So double quotes, which is not seen here, then you put 2x engraves, and then you put on mouse over alert, and let's see. So what we see in view sources, it is perfectly legitimate. However, when you pull it by a get HTML and put onto set HTML, again, I don't know why would I do this, but you have features, functions, requirements, so things do happen. So yeah, you have a XSS here. Okay. So with that, there's one thing I promised. Okay, so this is, which one is this? Uncoded. Okay, I think we covered, okay, yeah. So this is, we covered this already. So before I move on to the, okay, I don't have those. So what was happening was I was doing my slides when sitting outside, so I took some screenshots. I did not paste it here, but sorry for that. Now, in this demo, I have a Node.js application, and as I mentioned, eval is very dangerous. And in this particular program, I'm using eval in the backend for doing something, and let's see what happens. So let's say I have this crappy application, and it does something with something you sent to it. Now, for some reason, it is using eval at the backend. And what can happen is because eval is code execution, it hits the JS interpreter. On the client side, it is XSS and browser ownage, but on the server side, you can do a lot of things. You can do defacements. And if you want to be nasty, you have an enemy, don't do that, but that's what somebody could do. Do a denial of service, increase your debt. So, okay, so I'm going to restart the program. So let's now try to do something more productive. Try to read some stuff and install some bad things. So what I'm going to do here, I'm going to call another JS function, require file system, and let's try to read what the directory structure is like, what do they have. So I'm reading the app root. So this is the directory structure. You get to know all the files, and then you can essentially call those files and see what content is there in it. So let's try to read the files. Index.js is your main file, which probably gives you most clues. So this is the code that we get. If you want to be more nasty, you can probably upload something. So let's try doing that. So there are a lot of ways of doing it. I am not so good at Node.js, so I just use some function from somewhere. It said you have to put the data into base64 and use this function to write into the file system. So I used that, and that worked. For this demo, I had to read from paper and write it down here. So it'll take a few more seconds than usual. And then you specify the encoding time. Maybe there's an easier way. I didn't find it. Okay, so we are set. And then we specify the encoding that we are supplying. I'm pretty sure there are better ways of doing this much faster. Okay, and when you do this, you're going to essentially have the eval2 file. And if it was some .js, you would have ownage of the server. You could install anything. Now, let's go back and see what happened. So the request, as we see, was received. And if all is good for the attacker and bad for the victim, you should be having the file, which is there. And when you open that, you see whatever was there in the base64. So that is doing server-side injections with eval. And just wrapping up on whatever we discussed today. It's always good to use auto-escaping templates. Now, within YUI views, you can use handlebars. In Mojito, you can use handlebars. So that eliminates a lot of issues, I would say 70%. And when you're doing that, beware of using triple braces and doing unescaping. And always use set text. Always treat data as displayable text, not as HTML. Use DOM construction, which is a third takeaway. Fourth one is beware of context if you're going to be using something which is not HTML, something like onload handlers, CSS, URLs within the JavaScript. Always be careful of what to do. Don't use eval. We saw why. And always JavaScript encode, there are browsers like IE, there might be some new browser, they might just say, okay, I'm going to try to sniff. So if you know you're sending an application /JSON, always JS encoded so that, there's no way for a browser to try to be more smart. So the last one is use quote your strings. Okay, now there's several other edge cases, which I've not covered here. But having said that, if you use the top 3 or 4, I would say 5, or so the top ones, you're going to be getting rid of nearly 90% of the XSS issues. And why I'm saying 90% is because, okay, so there's another last demo. So this is XHTML application, and interestingly, it has encoded data within a JavaScript. This will not work in a regular HTML just because XHTML has some other rules. It will execute even if it is encoded. So you have several such edge cases. So so if you use the main rules, you should be fine for 95% of cases, and rest you need to figure out what you're using and what are the differences in those engines, languages. Okay, so that's all I have. And the next talk is from my colleagues, Dimitri and Albert. They're going to talk about how to test YUI applications for security. And thank you.
Thank you, Bishan. We have time for just a few questions. Does anyone have questions here?
So how does it feel to be working in security and knowing that these problems have been well known for 10 years and we're still talking about and teaching people how to sanitize their inputs?
Probably I shouldn't answer that, but I know some people might just reach me later. But the idea is I see a big gap between security folks and dev folks. They don't work together. If I had that maybe reach, and I could potentially tell people, but the idea there is it's always business versus somebody will say, okay, I put this feature, this thing's going to break, you're going to lose money. So from what I understand and what I think is correct as well is that it is about business first. So you need to run your business. If you make everything secure, probably something's going to break, you're going to lose business. So that is why I had so many recommendations, just pick and choose. Now, if you are going to be a high classified application, you definitely need to put security on the top. But then let's say just going to be there for fun, maybe you can just leave it. But I wouldn't recommend even that because you can be a launch pad for another attacks. But I think that's the case. The two industries, they don't work very closely. And there were a lot of good recommendations, I think, in ES4. They were not implemented. So for instance, if you look at the entire internet model, it is completely broken. You have advertisements running onto your browsers. They're coming from God knows where at the end. And they have full access to your DOM. And they can do anything. So it is not a secure environment already. And if you try to make it secure, you're going to lose business because those ad agencies cannot support it. Now, even if you are not having advertisements, if you're having a regular application, you're going to call some of the widgets, some social widgets, and there is no good security model in the browser to support it. Now, that's another thing. Now, there's so many new extensions that keep coming up. They keep getting popular. They have their own engines and all. And even if you secure all of these, that's why I said if you're going to be having a new engine tomorrow, let's say Flash next generation, whatever, so it might have some new feature to do something. So, yeah, thanks.
Any other questions?
Do you know any good scanners that you can recommend?
Good scanners. Are you from Yahoo? Okay. All right. So I've done, I've done pen testing for nearly 10 years. And if you ask me honestly, in my assessments, 20% probably are the results which are caught by scanners. Rest is all manual. And it is extremely difficult, painful. And in the context of JavaScript, it's extremely, extremely difficult, extremely, extremely, extremely painful because so many libraries, there's not enough good encoding tools, debugging tools. And there are some companies who have come up with scanners. They've been there for a decade, but you see, security issues are there. But if you want to be taking one advice from me, I would say cross-source scripting is a single biggest issue. And I always believe it is safer it is easier to code safely than to write application and just wait for a scanner to find it.
Any more questions? Oh, one in the back.
Just speak loudly, I guess. What about JS Lint as a scanner? How much? I mean, it's going to tell you not to use eval, but
Yeah.
Well, I was just thinking, how effective would JS Lint be as a scanner? Considering that it'll tell you don't use eval, be careful of using regular expressions.
Right.
That
So I
sort
think
of
the
thing.
next talk is going to cover a bit of it, but from what I can share, it does find some of the potential issues, not just eval, like global pollution and all. Now, if you're making, let's say you're having NPM modules at the back end, or if you're calling multiple libraries, you're going to have some sort of issues. Always good to, I've heard people, I've not used JS Lint myself exhaustively. I've heard JS Lint a little bit more strict and JS Lint a little bit less strict. Having said that, I don't think you have good scanners. They can probably point you to global pollution and eval and some of the other abusive things, which can be abused essentially, but it's not, okay, so let me put it this way. It is not that usable. You need something which can really tell you, where the issue is exactly. But if you have too many things, it is very difficult. I think Albert will cover that.
Okay. Thank you very much, Bishan.
Thank you.